In this video, we're going to talk about using Desmos.com to visualize one-dimensional motion. So we're just going to use Desmos.com, and this is our position function here. F of t equals cosine t plus t. All right, and so we would just come here to Desmos.com and click on the Launch Calculator button, and then type our position function in here. And then basically we'll just turn that off. We don't want to really worry about the graph of the position function. Sometimes people get that confused, like with the path that the particle is actually taking. The particle is not really like traveling along this graph, but just on the number line itself. So we're just going to turn that off. And then I'm just going to use the x-axis as our number line. So what you would do is go over here. I'm going to click projector mode because it makes it a little easier to see the graph. And so here I'm just going to turn the grid off because we don't really need it for this problem. So just by clicking here, that will turn the grid on and off. And I'm going to use the x-axis for the number line. So I would turn the y-axis off like that. On some of the free fall problems, it makes more sense to have it vertical like this. So you can turn the x-axis off and use the number line here for your coordinate system. Okay, so next up I need to put the point on there. And to do that, I am going to type in f of a, and the a could be really anything. It doesn't really matter. B, C, A. The one thing it can't be is t, right? Because Desmos will reserve the t for something else called parametric plot, and so you don't want to actually use t. That's why I need to use another variable. If I do use t, right, it will react like this, and that's really not what I want in this thing right here. So I'm going to use a, some other variable. Just remember that that just represents the time here. And then you'll notice if I type in a, it'll ask me to add this slider right here, and then I can move the point back and forth, right, with the slider like this along the number line. If you are having your coordinate system vertical, then what you want to do is do 0, comma, f of a. So that will allow you to slide it in the vertical direction like that. Okay, so we have our slider right here, and the default values for the slider go from -10 to 10. Even though it wasn't specified in the problem, right here we usually think about time as starting at 0. So if you want to adjust that, just go up here to this little gear button and set the bounds for a. Say we want a to start at 0, and we will just go to 10, I guess is probably okay for this one. In some problems, they will specify, hey, we only want you to go through from 0 to 5, let's say, and so you would just put the upper bound in here. We don't really have any upper bounds on this one, and so we'll just go to 10, some number like that, and click done. All right, we'll put the slider back to 0. You can zoom in and out on the number line with these zoom buttons over here. If things get really out of whack, you can press home and it will go back to a standard view. If you really want to customize where your x-axis goes from, you can customize here and also the y-axis like that. All right, and so when you want to set the particle in motion, just click play. All right, and it will start running. So there's a couple of things to look at right here. One of these things can be pretty confusing. Let's start with the simple one first. If I have here, you can see it says 1x. So I can either speed up the motion, make it go faster, or I can slow it down to take a better look at it. So I'm going to slow this one down a little bit. The other thing is confusing is right here, you can see you have these two arrows here. So what happens is when this bottom arrow is turned backwards, when it hits the upper bound here of 10, it's going to start reversing, right, the time. So this is sort of going backwards in time now. And so just remember that if you choose to have it like this, that when that slider is going backwards, that's not really how the particle is moving, it's just reversing it. So basically you're playing everything in reverse. If you don't want it to do that, right, then what you can do is click here on the bottom arrow, and then what will happen is when it gets to the upper bound, you'll see it will start back over here at 0, and then just keep playing it over and over again. So really here we're just playing the first 10 seconds of the motion over and over again. I kind of prefer that because it can be confusing if you look at the glance away from the screen and then look back at the particle and you see it moving backwards but don't notice that the slider is moving backwards, right? You can think that that's the motion of the particle. So if you set it forward, right, then whenever you're looking at it moving, it's always the motion of the particle if they're both forward like that. It just loops that over and over again. So that's the kind of setting that I prefer on this one. All right, for this one, if I actually increase this a little bit, say to 20, what's going to happen is that the particle will go off the screen, right? And it's never really coming back, right, until it resets over here. The reason for this is because, well, as t goes to infinity, right, this expression right here is going to also go to infinity. So the limit as t goes to infinity of f of t is infinity. So what that means is that this particle, right, the farther you let time run, right, its position on the number line is going to keep going off to the right. So eventually, right, if you let the time run far enough, it's going to run off the right edge of the screen right here. So, you know, you can always zoom out and adjust. Here, if you click and drag, you can adjust the number line here. All right, and so there you can kind of get a good idea of what's going on with the particle here by graphing that out. So Desmos.com is just a really good tool for actually being able to take a look at the motion here that's being described by the function.